Okay, I'm going to start by redoing this question 9. I kind of messed it up. So let's find the first derivative. 12x to the third minus 12x squared. I believe I took the wrong derivative in the last one. It was just throwing me up. Now I'm going to set this equal to 0 and figure out what my, yeah, I think that's what I did. I took the wrong derivative. So I can factor out a 12x squared, and I'm left with an x minus 1. 12x squared equals 0, x equals 0, x minus 1 equals 0, x equals 1. So right now I have two critical points in increasing order. So I want to check some signs. So this is what I did. I actually went to my calculator and put this function in. Okay? And then I went to the table. And I was able to see anything less than 0 is negative. Between 0 and 1, it's negative. And then over 1, it's positive. So what we have here is, since it changes from negative to positive, this is a minimum, right? A negative slope to positive slope. So our minimum is at 1. This critical point is neither a minimum nor a maximum. So we do not have a maximum, and that is x. Okay, so this is us using the first derivative test, right? And the critical points are always found by taking the first derivative and setting it equal to 0. So now, if you took the original function and graphed it, let me just go back and make sure I put the right function in. So I'm going to put 3x to the fourth, kind of got myself, minus 4x to the third, plus 1, and I graph it. It looks like this one here. So at our critical point at 1 right there, right? Critical point here where the slope was 0, but this is neither a max nor a min, and this happens to be our minimum. Okay? Let's look at this one. This one says find the constants a and b so that the minimum for the parabola is given at this point. So if it's a minimum, that means at x equals negative 1, the first derivative had to be 0 because it's a critical point. But also, because we know this point, we know at x equals negative 1 that the original function, dang it, was 6. So I'm going to write myself some equations. So if I take the first derivative, it's equal to 2x plus a. All right, and I said the first derivative at negative 1 should equal 0. So that's 2 times negative 1 plus a. I can solve for a, can't I? Turns out that 0 equals negative 2 plus a. I'll add 2 to both sides. A equals 2. Well, let's go back to the original. I'm going to put x squared, and I know a is 2, plus b. So at negative 1, this thing should equal 6, shouldn't it? So I'm going to put negative 1 squared plus 2, negative 1 times 2 plus b. 6 equals 1. This is minus 2 plus b. 6 equals negative 1 plus b. Let's add 1. b equals 7. So a equals 2, b equals 7. So what I did was, to double check myself, I went back and put in x squared plus 2x plus 7 into my calculator. I looked at the table, and where x was negative 1, sure enough, y was 6. Okay? So in that case, we had to write a set of equations to solve. All right, this one says find the global maximum and minimum on the closed interval. Well, again, critical points. We have to take the first derivative. So the first derivative of this is 3x squared minus 6x. Let's set that equal to 0 and see what we get. I can factor out a 3 and an x, and I'm left with x minus 2. So 3x equals 0, x equals 0, x minus 2 equals 0, x equals 2. So I have two critical points. Now, I need to figure out if they're max or mins or what, right? So if I want, I could take the second derivative. The second derivative will be 6x minus 6, right? So at x equals 0, this is 0 minus 6. This is negative, isn't it? So if this is negative, that means concave down. So the global maximum oh, if it's concave down, did I do that right? Yeah. Okay. At x equals 0, it's negative. That means concave down. So this should be a maximum. The global maximum is at x equals 0. Okay, we're going to figure that out in a minute. Because we want to check the edges, don't we? Now, let's look at what's going on at x equals 2. Okay, this at 2 is 2 times 6 is 12 minus 6. It's positive, right? Okay, if it's positive, that means concave up. All right, so at x equals 2, that's a minimum. But again, we have to check our edges. So let's do this. We're going to check at x equals negative 1, x equals 0, x equals 2, and x equals 3. We could graph this in our calculator and go to our table, couldn't we? I'm going to go to my y equals and graph the original function, x to the third minus 3x squared plus 4. I'm going to go to my table. I'm going to say start at 0 and do this. Okay. So at negative 1, I'll do y equals 0. At 0, it's 4. At 2, it's 0. And at 3, it's 4. All right, well, we already knew that we had a maximum here. But guess what? We also have it at one of the edges, right? And that's 4. And we knew we had a minimum at 2, but we also have it at the edge, negative 1. And that's 4. Okay, now they want it in increasing order. So when you input it, we got to put 1 there and 2 there, don't we? But that should be it. We always want to check those edges, okay? A global max and min means that it's the maximum for that entire interval. A local max and min is just a point where the points around it, like a max, where the points around it have a lower y value, or the points around it have a higher y value. But there could be a whole bunch of those in the interval. All right, but we're talking just about global. Okay, the next one says, find the global max and min on this closed interval. Again, we have these edges we have to deal with. So let's take our first derivative. 1 minus, remember that the derivative of the natural log of x, right, is 1 over x. So I have this 2, natural log of will be 1x over 1. So this is what it looks like, right? 1 minus 2 over x plus 1. Now I'm going to set that equal to 0. So let's add this over, and we get 1 equals 2 over x plus 1. I can write this as 1 over 1, can I, and cross multiply. All right, so x plus 1 equals 2. X equals 1. Let's see what we got. I will If we want to find, I know something's happening at 1, and I got to look at my edges. So let's look at x equals 0, x equals 1, and x equals 2. Okay, I'm going to go here and get some values. This is x minus 2 natural log of x plus 1. I really just want to look at my table. So at 0, this is 0. At 1, this is negative 0.3863. And at 2, it's negative 0.1972. So notice, this is the maximum value, isn't it? This is the minimum value. We got this from our critical points, that's fine. So the global minimum is at 1, and it's something on the order of this. We may want to use more digits when you input it, I'm not sure. And the global maximum is at x equals 0, and it indeed is 0. Okay? So when you have these closed intervals, you have to look at the edges. All right, so question 11 actually has 2 pages. Well, let's see what we got. If f of x equals x to the 10 minus 10x, let's take that first derivative. 10x to the 9 minus 10. So we're going to set it equal to 0. We'll add 10 to each side. 10x to the 9th equals 10. We'll divide by 10. X squared, I'm sorry, that's a 9. X to the 9th equals 1, so x has to equal 1. So that's our critical point, but we want to look at the edges. We have x equals 1, but our edges are x equals 0 and x equals 2. All right, if I want, I could decide whether 1's a local max or min by taking the second derivative, couldn't I? So that would be 90x. Now at 1, double prime at 1 is a positive number, which means it's concave up. So at 1, it should be a minimum, right? So it has a local minimum at 1. All right. Now, this is where we want to figure out the values of these things. If I go here to my original function at x equals 0, right? Y equals 0. At x equals 1, 1 minus 10, it's negative 9. And at x equals 2, it's 2 to the 10th minus, turns out to be something like 1,004. So its local minimum is at 1. Its local max, well, I don't see any critical points in there. I think if it's a global max, you could call it a local max. If that's true, so my question is a local max considered global max? I think it is. Right, if you only have 1. So that would happen at x equals, oh, it is, yeah. At one end over here, at 0, it's higher, and at 2, it's higher. So if I look at the graph of this thing for a second, see what this graph looks like. And my interval is from here, 0 to 2, right? I'm afraid I don't have the right thing. Let me get the right thing in there. X raised to the 10th minus 10x. So now we're going to graph it. What we're going to find is this thing goes way up. So this hits here, comes down to negative 9, and then goes way up. So that could be considered a local, and that could be considered a local. So 0 and 2. And then 1 is our local minimum. Happens to be our global minimum, right? If we look on the next page then, if it has a global maximum, what is the one largest maximum point in that interval has to be 2. It's the largest y in the interval.